Halogenoalkanes are useful compounds in synthesis. Consider the reactions that start with the halogenoalkane M shown below. Outline a mechanism for reaction 1. Okay, so reaction 1 starts from a halogenoalkane and it makes an amine. So this is going to be the reaction with ammonia. So let's start just by drawing this compound out, CH3CH2. Let's display it around the hydrogen and the chlorine. Let's do ammonia here, lone pair. So we're going to have a curly arrow from there to there. That's going to give us our intermediate. I've forgotten the other arrow, second arrow here to here. CH3, CH2, C, H, CH3, N, H, H, H with a positive charge on there. And then we're going to have a curly arrow from here to here, which then gives us our final product. Okay, so 1 mark for each correctly drawn arrow, 1, 2, 3, and 1 mark for the correct intermediate. Okay, part B, the infrared spectra below shows those of the 4 compounds N, M, N, P, and Q. We need the one that corresponds to compound P. Compound B has a carbon-carbon double bond. R isn't in there. Let me just circle that as that's not been in there, but Q could be one of them, which has got an OH. So the carbon-carbon double bond, what we're looking for is a peak between 1620 and 1680. So 1620, 1680, so not there, not there. However, with these two, you can see that it could be the third or the fourth, because they both fall into that range. However, you do have an OH, a very small amount of OH here, which suggests that this one could be the carbonyl that we've got in Q, and a little bit of R with the carbonyl here. So I think from that P is likely to be number 3, which is here. Give the IUPAC name for compound P. So it is butene. But if we go back to this, you can see that we've got the Z isomer of this, so I need a Z in front of this as well. Part D, draw the repeating unit of the polymer formed from P. So if I start with the monomer, and then if I extend this and remove one of the bonds that I've got in here, that gives me that. And then for reaction 2, just check reaction 2. Reaction 2 is forming the alkene. So the reagents for that is sodium hydroxide or potassium hydroxide. The conditions are going to be in ethanolic conditions, so ethanol, and then the reagent is behaving as a base. So this is an isomer of Q. Let's go back to Q. Let's have a look at what Q is. So Q is an alcohol. This is something completely different functional group completely. So this is a functional group isomer. And then for number 4, this reaction here, so we're going from an alcohol to a ketone. So this is going to be oxidation. And the reagents are potassium dichromate and sulfuric acid.